Good morning, friends. I hope chemical engineering students must have done very well in heat transfer and thermodynamics because the questions asked were very simple. Yet the paper is officially not out. Memory based, we have been able to collect some questions from the students. I will be discussing those questions which I feel are simple as possible that you can think of. In heat transfer, the first question the overall heat transfer coefficient for clean surface U for clean surface is 250 watt per meter square Kelvin. And the resistance of fouling 0.001. What will be the overall heat transfer coefficient for delta surface? One upon U clean is equal to 1 upon U delta we have to calculate. So U delta surface is 1 upon U clean surface plus fouling resistance. 1 upon U clean, 1 upon 250. Fouling resistance is 0.001. 0.005. So U for the delta surface will become 1 upon 0.005, which is 200 watt per meter square Kelvin. This was the first question. Second question, which theory is used to calculate the thermal boundary layer for the vertical plate condensation? Vertical plate condensation, we had taken the Nusselt's theory. Third question, a straight fin of uniform cross-section and adiabatic tip has an aspect ratio L by D of 4. If Biot number is 0.04, then fin efficiency in percentage. we had derived expression for the efficiency and then for the effectiveness. For efficiency, if you remember, it was tan hyperbolic ml upon ml. So we have to determine the value of ml. M is under root of hp upon ka, and if I take L within the square root sign, it is L square. H parameter is pi into d upon k, pi by 4 d square into L square. This pi gets cancelled and this becomes, and this d cancels, 4h upon k, 1 L I can put, and then I can put L upon d. Four HL upon K is Biot number. L by D is the aspect ratio. Biot number is given as 0.04 and aspect ratio is given as 4. This becomes under root of 64, that is 0.8. Thus, this fin efficiency becomes tan hyperbolic 0.8 upon 0.8. If you see this, it is 0.83. That is, efficiency is 83%. I don't think any point requires clarification, but still, if any one of you is having any doubt, you may ask. Fourth question, it is a double pipe heat exchanger. Hot medium is flowing inside. Cold fluid is moving outside. Hot temperature variation is 80 minus 3x and cold temperature variation is 20 plus 2x. And this length of the heat exchanger is given as 10 meter. Here x is equal to 0 and here x is equal to 10. When x is equal to 0, TH1 is 80 degrees centigrade, and when x is 0, Tc1 is 20. For hot fluid, the temperature will keep on decreasing. For the cold fluid, the temperature shall keep on increasing. So when x is 3, Th becomes 80 minus 30, that is 50. And for cold fluid, it will become 20 plus 20, 40. Thus, delta T1 becomes 80 minus 20, 60 degrees centigrade. And delta T2 50 minus 40, 10 degrees centigrade, and we are required to determine the value of LMTD. So this is 60 minus 10 upon log of 60 upon 10. This is 27.9 degrees centigrade. The important point was only to analyze. This type of question has never been asked earlier. The exact values of the temperature used to be given. Now they are being governed by this equation for TH as well as TC. Then delta T1 minus delta T2 upon log of delta T1 upon delta T2, that is the LMTD. Thus, friends, we have been able to get only these 4 questions, memory based. Next, as soon as we get other questions, I will be there with you to solve the questions. Thus, you will find that the 4 portions asked, this may be of 1 mark, the rest of them will be of 2 marks each. So 7 marks heat transfer for the time being. I hope within a day or so, we will be able to get the other questions from the students, memory based. Now let us see the problems asked on thermodynamics. This time, unfortunately, much importance is not given to thermodynamics. Only from pure gases based on van der Waals equation, one question has been asked, and other question asked is very, very simple question based on entropy equation. The reduced pressure equation is given as PR is equal to 8TR upon VR square minus 1 minus VR upon 9. And the critical compressibility factor is given as 3/8. We have to calculate Z. or van der Waals equation. VR is given as 3, TR is given as 4 by 3. PR, VR, TR, they are the reduced parameters. Any reduced parameter is defined as the local value of the parameter divided by the critical condition parameter. P upon PC is PR, V upon VC is VR, T upon TC is TR. And we know for van der Waals equation ZC is 3 by 8. If VR and TR are given by these two results, then we have to determine Z for the van der Waals equation, where Z is the compressibility factor. So, question seems to be very simple. PR, the reduced pressure, 8 into TR, 4 by 3, upon VR square, 9, minus 1, minus VR upon 9, 3 upon 9. This 9 minus 1, 8 gets cancelled. So this becomes 4 by 3 minus 1 by 3, that is unity. That is P upon PC. That means the local pressure and critical pressure, they are the same. When they are the same, Z is equal to ZC. That is 3 by 8. I don't understand why such a simple question has been asked. And the other question is, Cp by R is given by A plus Bt minus Ct square. We have to determine ds by dt. When pressure is constant, Cp dt, the heat transfer is Tds. So ds by dt shall become Cp upon T. And Cp is given by R into A plus dt minus Ct square. This is Cp upon T. And this becomes R into A by T plus B minus Ct. we have to calculate at the temperature of 1000 Kelvin. But A, B, C are not given. As a question given by few students. They never remembered whether ABC values were given. So when ABC, we will see in the final question paper, they are given T value given 1000 Kelvin, R value we know 8.314, we will be able to get the value of ds by dt. Thank you, gentlemen. This is the portion which we could get memory based from our students. If more students give more questions, we will be able to solve within a day or so further questions. Thank you.